Hello, everyone. Thank you for joining me today. So I have the pleasure to talk a bit about Liferay and Hystrix today. So you might ask the question, what does Liferay have to do with this little fella here? This is a porcupine, or also known as an Hystrix. We will get to this in just a second. First of all, I would like to set the stage and explain a bit what kind of problem I'm trying to address today. So in the center of all, we have our Liferay portal, which in a lot of cases is used for front-end integration of back-end systems within the IT. So we might have the REST services, we might have SOAP services. Also, we might connect our Liferay portal to a message bus, receiving event streams. And the biggest problem about this is that there are a lot of things that could fail in the back-end communication. So we only have control over what's happening in the Liferay portal. We have to expect that there are downtimes of the back-end systems, be it due to failure or even scheduled maintenance. Also, the back-end systems could overload and the response times could increase. So the Liferay portal, to still serve our customers with a good user experience, we have to deal with such situations. Also, we have a network in between. Network is not reliable in all cases, and there will be failure eventually, and we should deal with that in a graceful way. I think I could go on all day. There are tons of problems in distributed systems. There have been a lot of PhD papers written about that. So we know there are a lot of things we have to take care. I would like to introduce to you what Netflix, one of our favorite streaming services, how they approach this problem, because they have built a globally distributed service-oriented architecture. So they are leveraging this microservices architecture pattern in a global scale. They have thousands of servers all across the world in different data centers. They are mainly using AWS. And they are serving billions of requests each day. And for them, fault tolerance is a requirement for each service. It's not a feature. It's something every service has to provide. And they even go so far to test this on production. So what they do, they have a little program which is called the Chaos Monkey, that go through the AWS data centers and kills off virtual machines randomly on production. It introduces latency, and there's also the Chaos Kong. This one will kill off a complete availability zone on production, and the service still has to be stable and serve the customers around the world. And all traffic should route to one of the remaining data centers completely seamlessly. So each service, each developer knows when building a service, there will be failure in the back end, and they have to make sure everything works the right way. So they came up with some basic rules each service has to obey. So for all third-party service interactions, there has to be some kind of isolation. So they have to introduce timeouts. A request shouldn't take forever. It has to respond in a timely fashion. We have to limit the number of outstanding requests. So we don't want to flood our back-end systems that could be crucial to our business with tons of requests because our portal front end is under attack. Also, we should make use of isolation patterns, like the circuit breaker pattern. It basically states if there are too many requests failing in an amount of time, the backend service should cut off, so the circuit should break, and all requests should be handled locally and only periodically checking if the service comes available, and then start routing traffic again. Also, fail fast, rapidly recover, meaning our portal shouldn't crash if a backend service is not available. We should fail fast and if the service gets available again, we should detect that and start our normal work again. Fallback and degrade gracefully. Also, as I said, you shouldn't crash. You should have some kind of fallback logic. Sometimes you can take data from the cache, which is not as up to date as it would be when the service is available, but at least we can serve our customers some kind of answer and have at least a bit of user experience left. So, if you go to your developers in your portal and tell them, please, when connecting to our backend services, make sure you do all that. What would that mean for the developer? So for once, it would be a highly complex threading model behind that, because we are dealing with multiple thread pools, we are dealing with semaphores, pretty much everything you can find in the Java concurrency API, you will require to achieve that, such kind of isolation. And as everybody knows who has developed parallel systems, this is a really, really hard thing to do and to get right. Also, we have to deal with network timeouts and retries. We have to implement these nice circuit breaker patterns and swim lane patterns. So a lot of work for the developers. And that's exactly where we come back to the beginning, where this little porcupine or Hystrix comes into play. Hystrix is a fault tolerance and latency framework or a library developed by Netflix exactly for their for achieving high availability and resilience in their architecture. The good thing is Hystrix is a simple Java library, so we can throw it into our Liferay container and start using it. It's built on top of RxJava. RxJava is the Java implementation of the Reactive Extension developed by Microsoft. So I will get to this in a bit, what exactly the Reactive Extension is. So what Hystrix does is each backend call is wrapped into a so-called command. And the command will be typically executed in a separate thread. It doesn't have to be, but usually for isolation purposes it is. And each command can then be configured in many, many ways. So for example, we can set a timeout. If a request takes longer, Hystrix will handle the timeout for us. It will return, and we can continue our work. We can also configure a queue size, how many threads should be executed in parallel. We can configure the circuit breaker, the threshold, when the circuit breaker kicks in. There are tons of configuration parameters, but it's all configuration. We don't have to do the hard work. The heavy lifting is done for us. Yep. Okay. So also, Hystrix provides us with a callback, the fallback method. So if something goes wrong, for example, the request fails, we have a Java exception. If the command is rejected by the thread pool because we are currently under a lot of pressure, we have timeouts, or the circuit is broken. All of them will lead to a fallback, and then we can simply think about logic which is appropriate for this command to handle the fallback situation. Another neat thing we'll see in the demonstration later on is Hystrix emits monitoring matrices. You can subscribe to. It's an event stream, and you can see near real time how your backend requests, how your commands perform, and where a short circuit might currently occur. Okay, so what's the Reactive Extension? The Reactive Extension is basically a Java library. The concept, a Java library for creating asynchronous event-based programs. Somebody has visited the talk yesterday about event streams in OSGi. This is basically the same concept behind that. So the theoretical basis of the whole Reactive Extension is the observer pattern. Most of us know from the Gang of Four. What they have done is they have added two new methods, onComplete and onError. which means we can tell our observable can tell our observers, I'm done, I have no more messages for you, or if something goes wrong while receiving the events, we can also call back our observer. The reactive framework, on top of that, defines a lot of operators where you can concatenate observables and build up event streams and filtering them, select, transform them, and at the end, it basically acts like a push equivalent to an iterable. So I have a little sample for you here. So on the left, we have the iterable. The one big difference is that this is pull-based. So we have to get all our data first, then we can start skipping 10, taking the next 5, mapping them, and at the end we're iterating over the result. So this is a blocking call. It's not asynchronous. This one blocks. The observable, on the other hand, the producer pushes the values through the pipeline, and the values can occur whenever. So we are first describing basically our event pipeline, and at the end, when we call the subscribe, then we are starting to listen for events, and they can come whenever they want. So this can be synchronously or asynchronously. So how does this now fit into the Hystrix command? So there are two main classes we have to use in Hystrix. One is the Hystrix command, and one is the Hystrix observable command. The Hystrix command, usually you override or you extend one of both classes, and you will have to override the run method and the fallback method. That's all you have to do. And then you can simply call execute, which is the synchronous way which will only give you a single result. Also, there is a queue method. This one will execute the command asynchronously and will return you a Java future object where you can call the get and get the value whenever you want to. Internally, the execute simply calls the queue and immediately gets the value. So and then there is that's where the reactive comes into play. There is an observe method. This one will give you an observable back. And in this case, the observable will be already hot, meaning the command is already executed and will immediately receive or will be immediately executed receiving events or calling the backend. And there's also the two observable. This one is the cold version, so you will also get an observable, but it's not the command has not been executed yet. At the end, all of these types of execution of a command, they will end up in the two observable eventually. So how does the command work internally? So first of all, it will check if the result is already available in the cache. If so, we don't have to do anything. We don't have to call our backend. We can return the result, be done with it. Otherwise, if that's not the case, we will check the circuit breaker. If the circuit is open, we are not going to call our backend. We are immediately, the Hystrix command will immediately call our fallback method. Within the fallback, we have the possibility to check what went wrong. In this case, it will tell us, okay, the circuit is tripped. We won't process the command to the backend. If there is no fallback, the command fails. We can't do anything about it. If there is some kind of fallback logic we can do, we can return the results, and at least we can return something. If the circuit is closed, Hystrix will try to schedule the command in the thread pool. If the thread pool is too busy, the command might get rejected, and we'll also go to the fallback method and we do our fallback logic. If we were able, also this feeds into the calculation of the health status. So this will be a failed execution, telling the circuit breaker, okay, we're currently having some problems. If we are able to if Hystrix is able to schedule the command, it will call the run method for you, and you can do your backend interaction. You can call your REST service, you can connect to a queue and receive events, whatever you want to do. If this execution fails, host is not available, I don't know, the exception will be encapsulated by Hystrix. The fallback method will be called, and we have an opportunity to handle this in some other way. Also, it will monitor the timeout. So if the request takes too long, we won't do anything. The command will get cancelled. We will go to the fallback method and resume. If everything goes right, the method comes back. Our backend has responded in a timely fashion. We can return the result, and everything is good. So this is the logic that the Hystrix command provides for us. To give you some kind of, also, almost forgot, execute, if the failed execution or timeouts will also be reported to the circuit breaker. Okay, to give it a more practical approach and to show you what Hystrix really can do, it's nice to see something. So what I've done is, in my Liferay portal, I have a little demonstration portlet what will connect to a REST service providing Chuck Norris facts. Simple string. It's just a simple REST call. Also, I have registered the Hystrix event stream, and we will subscribe from another little Spring Boot application which provides a dashboard for monitoring Hystrix events. To get some load on the portal, there's a very simple JMeter included in this demonstration, and the code can be found on GitHub. So feel free to clone and play around a bit. Okay. So this is our portal. As you can see, I can refresh the page. There will always come up a different nice Chuck Norris fact. Also, you can see this is the Hystrix Dashboard. And what you can see here, these were the two requests I just sent through. This is a counter for the successful requests. These are the timed out requests or the ones that got rejected by the thread pool. These are real failures, and if the circuit is open, currently it's closed, as soon as it is open, this counter will tell us how many requests have directly been rejected. Down here we can see the thread pool. Multiple commands can be executed in a single thread pool, but that's just configuration. We have to tell it how the thread pool should be sized and which commands should be executed in which group. Okay, so let's get a bit of load on the portal so we can see how the dashboard reacts. I've started the JMeter test with only 10 users. And as you can see, we're already starting to see a lot of backend requests going to our REST service. Okay, this is one. This is the easy part, and we can have a look at the code. This is our command. So it derives from the Hystrix command. There's the run method, and there's the fallback method. In case we can't reach the backend, we have a hard-coded fact in here that can be returned. Up here, we have a bit of configuration. So we are setting the timeout and the thread pool size. So we are currently executing 50 threads to the backend in parallel. And if the request is not back in 200 milliseconds, we will cancel it. To demonstrate what happens if we don't take care of such things, I've created a little switch to turn off Hystrix. Okay. So now my portal directly connects to the backend service. It seems everything is all right, but now we're starting to introduce some latency. So our backend service will take about 15 seconds to return, which happens in reality. So we have to restart here. Okay, service is back up again. And what naturally will happen, our page will reload very slowly because of our latency in the backend. And if I now put some pressure on the portal, everybody knows what will happen now. So the portal will completely get unresponsive. Even pages where there is no backend interaction at all, the portal will stall. We have a complete denial of service. The whole portal is not available anymore because of a single backend service not responding in a timely fashion. So all our worker threads are basically waiting to get effect. So let's see what happens if we turn Hystrix back on. Maybe we have to kill him off so all the connections get. Let's see. It should respond by now. Yeah, here we go. We are back, and this is the default behavior. And let's turn Hystrix back on and start the backend. Okay, we still have the latency in here. Oops. Okay. Dashboard should be still available. And now let's start the... As you can see, the dashboard now reports that 100% of the requests fail because we have a timeout of 200 milliseconds. Our backend takes 15 seconds, so Hystrix will cancel the call for us, and you can see now here the circuit is open. We have too high of a failure rate, and all the requests, they won't even try to go to the backend. Only, you see this little 2 up here, these are the ones that go through just for testing if the backend is available again. And a nice thing to see now, hopefully, the portal should still be responsive. So here, the page has loaded. The page is loaded. We see our portal. The page will only deliver our fallback, but that's okay, because the backend service is not available. But the rest of the portal is not impacted at all. We have some load on the portal, but we don't care. So hopefully you got a good impression of what Hystrix can do for you. It's very easy to use. It's a simple library, and you will make a major difference when going to production. So thank you very much, and I'm open for questions.
Is Hystrix supporting some retry mechanism? That means if I want, for example, to send some requests to backend systems and it fails, can I try in 15 seconds, 30 seconds, something like this to maintain this request? Because what you have shown that if it fails, it goes, and then I don't have this trace when I need to retry this specific request, for example, user update in backend system or order update or something like this.
I'm not totally sure. I mean, you can reschedule the command in the fallback, but I'm not totally sure if there is an API supporting that directly.
I think that this is the missing point of Hystrix. So, okay.
Yeah.
Thank you.
The question is regarding the pools. You had that pool configuration within the application itself. Is there a configuration file for Hystrix? Like
So Hystrix internally uses Archaos, which is the configuration library from Netflix. And there you can have configuration files in the file system or load them from a configuration server. That depends on you. You can pretty much do everything there.
Any other questions?
Hello. Are there any downsides you can see using Hystrix?
Downsides, yeah. So one I experienced when building this demo was the OSGi support. So it's they have OSGi fight their jar files, but I had some. Usually you can change the configurations on the fly. But this is done by static method calls, and I wasn't able to get this working in the OSGi environment. Yeah, so that's one drawback, and you also have to take care, as always, to clean up afterwards. So it was I had to go into the activator of my services and reset Hystrix when shutting down the bundle, so the thread pools get cleaned up nicely. But there is a method for that in the Hystrix API, but you have to take care to call it at the appropriate point.
You can set timeouts using the normal API. What's the advantage of using Hystrix for the timeouts?
Where can you set timeouts?
For example, when you connect in SOAP servers, there you can there you can set a timeout on a connection.
But this depends on your client libraries. So there are, like HTTP connection, I don't know if there is a timeout in there built in, but Hystrix is generic. You can call any backend you want. It doesn't even have to be a backend. And it will guarantee you that the timeout will be and is easy configurable and encapsulated, and all the threading is done for you.